Welcome here to Gulistan for yet another technology presentation. I welcome one and all, both here in person and also everybody who's on the web. We're really very happy to have Dr. Suresh Kalathur today. He's accepted our request and he's come here to give some presentation on data mining. Dr. Suresh Kalathur is an assistant professor of computer science and director of analytics programs at Boston University Metropolitan College. Dr. Kalathur's research interests include enterprise Java applications, data mining, object-oriented design and analysis, application-level security, and autonomous agent systems. Dr. Kalathur teaches courses in programming languages and web technologies, analytics, and data mining. Prior to joining Boston University, Dr. Kalathur served as senior software engineer and principal investigator at Cognition Corporation. Dr. Suresh Kalathur has a PhD in computer science from Brandeis University, MS in computer science from IIT Bombay, and BTech in computer science from NIT Warangal. Thank you, Dr. Kalathur. You can get started.
Thank you very much. Right, so welcome to the data mining presentation. So last time we had the talk on big data analytics. Right, so we'll continue with the theme and look at in data mining in particular. So also there are too many terms people use, so we'll take a look at all the various terms and see where today's presentation fits into the picture. And then we'll tie in the various pieces in the upcoming talks as well. Alright, so we'll concentrate first on the first part with the data mining, and in the second half I'll show you the tools, especially the Vika and the R, how you can get started yourself with the data mining techniques. Alright, so we'll start with data mining, typical definition of data mining, and what is data mining. When people say they are mining your data, what are they talking about? And various data mining techniques, there are several of those. We'll just take a look at a few of these, and we'll try to relate to common applications that we normally use. Most of the applications, in addition to the data that is collected and stored in the various databases, we have a lot of data in the form of text, so the text mining is very important. And also a lot of data that we collect from the web, so web mining also is another area that uses the same techniques as the traditional data mining. So whatever the techniques that we see, could be applied into various ones. Alright, so and then the various terms that people use, they talk about data analytics. So before the data mining started, it was all machine learning. So all the in artificial intelligence they started, and then all the various techniques that they have been using, they described them under the category of machine learning. And then as collection of data became more and more popular, they started using those techniques on our data as well. Alright, so and then they wanted more meaningful ways of presenting the data. So data visualization came into picture. And then the data analytics term that people use today. So anything that has to do with data, so they describe it under the term data analytics. So the data analytics will include data mining, predictive analytics, data visualization, all the dashboards, scorecards, and so on. Everything they talk about, they just comes under the umbrella of data analytics. Alright, so when you go into the data analytics, so basically you see what is the problem that you are trying to solve. Are you trying to present something to the user, or are you trying to analyze the data and come up with the relationships between the data? So all those questions will determine what branch of data analytics you are actually using for that particular task. So we'll try to compare those with respect to our traditional one. Most of you use your traditional databases, and then you know how to do the queries, how to generate the reports. So we'll try to compare those against the data mining techniques and see how they actually differ. Alright, so the main purpose when people say they're doing data mining, they are trying to discover something about the data which they didn't know before. So those are the relationships that are there, or patterns that are there in the data, which are not obvious. Alright, so we're not looking at just a few records, so we are looking at several thousands, millions of records, and trying to see what lies within that particular data. Alright, so first we need a description of the data. So most of you use your traditional attribute relation model. So we'll use the same technique here as well. So the purpose of the data mining is the output. What is the output that we are going to show to the user? It is some model which describes what the data is going to be. And the purpose of doing the data mining is you need to predict what is going to happen with the new data that you are going to encounter. So most of the models that we are going to build has the prediction capability as well. So with the new data, what are you going to predict based upon what we have done? So once you did the model, so how valid is your model? Right? So that we need the test data. So when you start doing the data mining, obviously, you have whatever the data that you have. So you have to deal with the data. You divide the data between the training data to build the model and then the test data. And there are various techniques that people use for coming up with the training data and the test data. And then when we go to the tool, I'll show you some of those options that we have. So that will basically give you something, maybe it's valid, say 70% of the time, 90% of the time. So we'll have some idea of how our data mining model is going to be. And finally, it has to be applied in the real world. So if it is something about the customer data, so we need to apply it in the real world and see whether those predictions that you are trying to do today are actually indeed valid down the line. All right, so all those things we are talking about when we talk about the data mining, so we are concentrating on that problem. Before you actually start the data mining, so you need to have the data. Without the data, there is no data mining. All right, so it depends upon what you're doing. So your boss would say, okay, go and mine this data. All right, so the first question you have to deal with is, what is the data that you're going to actually deal with? And what is the problem that you're trying to solve? The data has to be meaningful. So you take any data, you do the data mining techniques, you can come with the model. But if the data is not meaningful, so whatever the model that you did is actually meaningless. All right, so and then the main technique, the main interest for us when we do the data mining, there should be something that you didn't know in the model. Otherwise, it's not data mining. So there has to be some hidden knowledge which we need to discover when we do the data mining techniques. So coming to that, so we have, are you doing the query on the data and you're trying to prove something, or are you trying to do some data mining on the data? It all depends upon what is the data that we are going to do. So we can classify our data into three categories. All right, so shallow, multidimensional, and hidden knowledge. All right, so our goal for the data mining is to uncover the hidden knowledge that is there in the data. The shallow knowledge, so this is pretty much the straightforward data that you capture. And then you can do the relational queries on the data and then describe what is there in the data. We'll come to the multidimensional one. So if you did the overlap with the data cubes and the data warehouses, so that's where we deal with the multidimensional data. All right, so the straightforward data, so I just gather the data about you and store them in the database. And then I just wanted to see what is happening with the data that I collect from you. So I can run some SQL queries against it and then generate the reports. So there is nothing much there. It's basically presenting what I have collected and then describing the problem that I'm trying to solve. Coming to the multidimensional knowledge, so whatever the attributes that you have collected, they have various dimensions. Right, so simple one is basically the time. When you're doing the analysis with respect to the time, you can do year by year analysis, or you can do quarter by quarter, month by month, and so on. And if you're dealing with the sales, so you have the sales for the country, for the various regions and the states and then the cities and so on. So it gives you more complexity of how you are trying to analyze the data. So that comes with the OLAP, and then the typical data warehouse tools or the OLAP tools that you actually use. Alright, so that's basically dealing with what is already there in the data and what you can learn from the data. The main technique for the data mining is to see what is there that we don't know in the data. Alright, so this is something that we cannot do with our relational queries, and we need some other techniques for actually capturing that one. So that's where the data mining comes into picture. So the first part of the talk will concentrate on the data mining, and then when we come later to the tools, we'll also take a look at visualization part, how we're going to present the data that comes to the analytics side. So and then we'll basically see what are the various tools that are available as well. Right. So if you whatever the data that you are trying to solve, so one is basically the queries or the OLAP tools, the first two types of category that you actually start with. So these are some examples. So if your problem is basically looking at the list of all customers and how did they pay for a particular item, in this case just pick the credit card for buying a refrigerator, or using the store card, or applying for the credit when you're buying the item and so on. So you want to see how many of those actually did that type of purchase and so on. It's a typical database query that you can do and get the data. Alright, so and then your HR would be interested in how many sick days you're trying to do and producing a report. So these are pretty straightforward techniques that you can use to gather the results and then show information about those. Alright, so those are just the query tools or the OLAP, depending upon at what level you are trying to do. So where does the data mining come into picture? Right. So now you have all your customers. So what is the profile of the customers? All right. So you get all these junk mail, and do you actually reply to that mail? So that's basically the target for these people. All right. So they are sending all those mails to you for a particular reason. You have been selected to receive those beautiful promotions, and are you going to take advantage of those promotions or not? So that is the model that they are trying to build. So what customers could they target so that they could get advantage out of them? So just blindly sending to everybody obviously is not the answer for that particular question. Alright, so and then you apply for the loan, and are you going to repay the loan? Are you going to default on the loan? So what is the profile of all the people who pay the loan on time and then who default the loans on time and so on? Obviously, we need the data for that. From the data that we have, so we are going to come up with the models describing those types of scenarios. Alright, so these are not against the queries. You cannot write a query for doing that one. So this is basically trying to predict how the data that you have would fall under these categories and trying to target those customers. There's some of the data mining techniques that, there are several of these. So we'll just take a few of these and see how they relate to the data mining branch as well. The decision trees, nearest neighbors, neural networks, rules, and k-means. And then we can see in real life where they actually come into picture. Right. So before we go to those tools, you wanted to do the data mining, so you pick one of your favorite tools and you start the analysis. You have to keep in mind that it's just a tool. So it's just going to give you a model. So what are you going to get out of that? So you are the business analyst in this particular case, trying to solve a particular business problem. And then you develop the model. So it's a tool to assist you in coming up with the model. So blindly, you cannot just take the result and say, okay, here is the model that you have. You need to be able to explain how you arrived at the model. So what are the relationships that you have uncovered? And you need to apply in the real world. So that is the main goal for us. What is the purpose of this one? All right, so you have to verify in the real world. And then all the data may or may not be applicable when you're doing the data mining. So of all the data that you have collected, how many are you going to keep? How many attributes are you going to keep? How many attributes are you going to disregard? So all those things we have to uncover. Some of the tools are pretty straightforward. Those are called unsupervised, and some of them require your supervision. That means you need to understand what the technique is about. It's pretty little supervision that is needed to come up with the results for those ones. All right, so coming back to the examples, so what is your goal when you're doing, say, for example, you're trying to come up with a list of all customers, and going with the mail, it could be an email campaign, whatever it is, and you want people to sign up for something. All right, so your goal is basically to get as many customers as possible. So you cannot, how are you going to describe that particular problem? So if you just try to describe in English, so your boss would say, okay, we need the more response from this direct mail campaign that we are trying to do, but how do you translate it? So that statement itself is vague. How do you going to translate it itself into the problem? All right, so what are the characteristics of the people who actually respond to your direct mail offering? So what are the patterns between those relationships? All right, so for that, we need to go back to our statistics. All right, so obviously most of you did the statistics. If you're in the field, obviously you're still doing the statistics. But for the rest of the people who are in the IT field, so the statistics is basically something we did long back, and now we cannot escape it. Everything now is back to our statistics, the basics of statistics. We are back into this field. All right, so and obviously it's going to help you. It's not to replace you when you're doing the data mining. All right, so data mining is not data warehousing. So some of you actually use the data warehousing tools to analyze the data. It's not your SQL queries that you're trying to do, not the reporting services that you use to generate the reports, not the overlap going with the data warehousing, and it's not data visualization. So most of the times when a lot of companies, they basically show you beautiful dashboards, how you can play with those dashboards and then see what are the patterns in the data. But that's just a user interface for you behind the model. That's not itself the data mining. It's just a visualization tool for that. Alright, so comparing with the overlap, so they are basically two different tools. They complement each other. Alright, so when you're doing the overlap, basically it's a decision support system. So you already have the data in the database. You're trying to analyze what is there in the database. So what do? So you run the queries and then you see whether they are true or false. So that's where your SQL or overlap will come into picture. So you form a hypothesis and then you verify whether the hypothesis is correct or not. So you know here what you're trying to test when you're doing the overlap or the SQL. When you're doing the data mining, you don't know what you're trying to test. You want to uncover what that hypothesis is from the data that you have. Alright, so here is an example. So again, you collected information about all the people who you gave the loan and how many of the people are actually defaulting on the loans or not. So once we have the data, so we want to see who are the people who are actually defaulting on the loans. So people with low income, so are they the ones who are defaulting on the loans? Alright, so are different characteristics of the size of the household and so on. So there are various attributes which would describe the relationship. So you can use the OLAP, you can come up with the query for verifying whether that is true or not, and then you can prove or disprove that particular hypothesis. So for those things we can use the OLAP. How about the data mining part? So we want to uncover what that pattern is. So what you are trying to test against the data and uncover those. So what are the factors that so if the person has the income less than 25,000 and the size of the household is between this one, then they are likely to default. So can you come up with a rule like that? So that's where the data mining comes into picture. Right. And that's one part of the data mining. There are several techniques that we have seen. All of them will come into picture. Right. So basically they complement each other. So in one case, you can come up with these rules using the data mining techniques. You have to verify it against your data. So that's where you're going to run the queries against the data and then verify that they are true or not. So a model is not going to give you 100% accuracy for the data that you're going to use. So whatever the accuracy that you're going to establish is after testing what you have with the data. Right, so the classical techniques, so we'll briefly take a look at this and how you can apply in your real world. So the classical ones, these are coming from directly from the statistics. So you can use Excel, say for example, if we have small data sets or all the various tools that we have, they give the capabilities. The clustering and the nearest neighborhoods, so those are some of the classical techniques that people use. And when we come to each one of these, we'll try to see what those are. And then the decision trees, neural networks, and then association rules. Those are some of the techniques also we normally use in our day-to-day life. So coming to the statistic part, so this is where the prediction comes into picture. So you want to come up with a model, so using the classical statistical techniques, regression and so on, so we can come up with a model to describe something is true or not and what is going to happen with the new data that we are going to get. Right, so it is giving us a model, a different kind of model, and depending upon what technique that we are going to use. So we are going to say this is the pattern, and then we can give some results for the pattern. So comparing it against the visualization part, so whatever the data that is given, so we have some information about the customers, and here basically the color of the eyes, so how many of them have blue color, brown color, and green color, whatever the colors that we have. So this is the data that we have collected, and then we can take a look at this and then come up with some conclusions. So starting with the basic statistical tools that we have, pie charts, histograms, bar charts, and so on. So using the data visualization part, so we can have some understanding of the attributes that we are trying to analyze. And once we know what those attributes are, then we can go and establish the relationships between those. All right, so they could be discrete or continuous. So those are the two figures depending upon the attributes that we actually collect. The classical way that they describe the minimum, maximum, the mean, the quartiles, and so on. So all those, any of the statistical tools, even the data mining tools that we see for numerical attributes, they are going to describe what these are. So looking at those will give us some idea about the attributes and then the relationships between those attributes. Alright, so under the statistical techniques, the commonly used one is the regression technique. So we'll start with a very simple one. We'll just take a linear regression here. We'll just have one input and then one output. So this is the variable that whatever is the input that we have, and this is the variable that you are going to predict. Alright. So whatever the data that we have, so those are all the points for this input, that is the output. So assuming that those are the numerical values. Alright, so it could be the age versus the income and so on. So whatever the two variables that you are going to pick. So one is your predictor and one is the prediction, the value that you are going to predict. Right, so this is the data that we have. So what do we do with the data? What are we trying to describe about this data? So if you think that there is a linear relationship between this x and then the y, so you want the best fit of the line that describes all of these points. Obviously they are not on the straight line. So there are various lines that fit into those patterns. And obviously we have to pick the best one, so there will be an error associated with those. And then you would pick the one with the least error. So once you do that, so what do you get out of that particular model? Alright, so here is an example. Alright, so whatever is this variable, so typically in the straight line, so we have the y equals mx plus c, that is the relationship that we have. So the b is the slope and the a is the intercept on the y-axis. So say for example, the bank, whatever is the bank that you are using, So the bank manager looks at all the customers, and then they want to approximate average daily balance that you are going to carry for your customers, for all the customers that they have. Alright, so assuming that the income or whatever is the deposit, the direct deposit that you are doing, so that is the input that we have, based upon that they want to predict at the end of the day how much balance is going to be there for this one, or at the end of the year, whatever it is. Alright, so looking at all the data, then maybe they came up with the relationship like this: 1,000 plus 0.01 times the customer's annual income. Alright, so the initial value is, say, for example, the initial deposit from that line. Probably it looks like the initial deposit that all the customers have to maintain the minimum balance. And here is basically saying that 1% of your annual income you are basically keeping as your daily balance. Right? So that will basically give you a relationship between those. So, and then you can compare against various ones. Alright, so here, so on the x-axis, right, so so we don't have the face to pick and pick validation. Alright, so here is basically say the years of your marriage, and then here is every year what is the value of the gift that you are giving to your spouse. I just picked one of you is the husband and one of you is the wife. Alright, so maybe your lines are going up and up and up until whatever happens after that point, or maybe it is like me. My wife just stepped in, so I can mine is pretty flat. It's not even there, it's basically at the zero. So yeah, so depending upon what is the input and what is the output, so you can come up with the relationship between those and then describe. Alright, so for example, for Venkatesh, Geeta is expecting a big gift next year, so she can anticipate what is the amount of the gift that she got so far, and then predict next year what it's going to be. Alright, so there is an example of the linear regression. And obviously it's not just one value, so obviously as you are aging, maybe something else, some other variable also comes into picture, so you have more than one variable when you are trying to come up with the regression, that is the multiple linear regression. Alright, so if it is a straight line, so not all of them are straight lines, and then some of them, when you describe those, we have the positive correlation, negative correlation, no correlation at all of those things will come into picture. So that is the classical one. People, the first thing that they do when they deal with the numeric values is to see if there is any correlation between the whatever is the value that you are trying to predict and all the inputs. The inputs could be any number of inputs. And once you start with that model, and then if you rule out that one, then we'll go to the next one and then see what we will do with those. Alright, so the next one, moving on, the nearest neighbors is another classic one that they use to predict about, again, whatever is the data that we are trying to do. Alright, so as the name suggests, it is the nearest neighbor. Alright, so imagine yourself in your neighborhood and you want to predict. Say for example, a new person comes into your neighborhood and you want to predict the attributes of that new person. Alright, so you look at all the people in your neighborhood and you collect the data about all of them, number of children, and then number of cars, and then their income and so on. So from the nearest neighborhood technique, so we can predict that the new person that is coming into the neighborhood approximately falls into that particular category of those attributes. Alright, so obviously there will be outliers associated with the data, any data. So most likely that's within one of those. Alright, so again, this is an example. If all of you, yeah, go ahead.
Somebody just messaged that your voice is breaking.
Oh, okay.
Somebody needs to be on mute.
Yeah, so one of you has to mute your speakerphone. Alright, so this is an example. So if all of you have an income, say for example 100,000, so your nearest neighbor in this particular case would also likely have 100,000 income. Alright, so it all depends upon how we are going to predict who is close to you in this particular case. So there are various applications. Good one is about the text, when you're doing the text mine. So you're looking at processing various documents and you want to see, you have a new document and you want to see how closely this document matches other documents. For us, when students turn in their term paper reports, all of them, I don't do this one, but there are various other professors who do this one. So it goes through this Turnitin and then it will give you a score. Alright, so the higher the score, the more likely you picked up all the material from the internet and then produced your term paper report. So for those types of things, so how closely your document matches the other documents. In all the other ones, so for example, the legal, in the legal field, so various documents that they have to process, and then you're looking up a case and you want to see all the other cases which were similar to those cases. So in all those applications, the nearest neighbor technique is used. Right, so similarly for the stock market data, if you are successful in predicting what is going to happen to the stock market tomorrow, so you can take a look at, say for example, the previous history, and you try to predict what is going to happen. Right, so it's just a model, so obviously it's not going to make you rich, and nobody got rich like that. So that's one example. So when you're talking about the nearest neighbors, so usually it's not a single nearest neighbor you're looking at, it's a group of the nearest neighbors, the K. So that's where the supervision comes into picture when you're applying the techniques. So you need to specify how many of the nearest neighbors you are looking at. Obviously you don't know, so you start with 1, start with 2, start with 3, and see how the model is behaving, and then determine whether that is valid or not. Alright, so here in this case, so we have income on the x-axis, the age of the person on the y-axis. So we collect all the information about whether they paid their loans on time or not, or paid your bills on time or not. So we have these ones on the squares who defaulted on those loans. And then we have this new guy C here. And then we want to see, this is the one who is applying for a loan, that is their income and that is their age. And then we want to predict whether we want to give the loan to them or not. So if we just take a look at the nearest neighbor, unfortunately that guy actually defaulted on the loan. So you cannot just make a determination on the single nearest neighbor. So you just expand your reach and then see if there is, within the nearest neighborhood, a majority of them are actually paying the bills on time, and then use that particular judgment. Alright, so whenever the nearest neighbor technique is used, so those are one application. And in real life also, so there are various places where they use the nearest neighbor. Alright, and then when we come to the applications, we'll take a look at those. The clustering is another important data mining technique that people use. Alright, so again, you take a group of people or a group of neighborhoods, and then you want to see what are the common characteristics where you can group each one of these. Alright, so how many groups that you can come up with? So again, that's where the supervision comes into picture. So you would go with, say for example, I want 2 groups out of this entire data, and how can you divide your entire data set into 2 groups? The purpose for the clustering is to make sure that the data that you have within a group is very similar to each other, and then it is different from any other data that is there in the other group. And then you expand. So suppose the data that you have, you cannot clearly distinguish into those 2 clusters. Then you go to 3 clusters, 4 clusters, and so on, until you can come up with a distinction of those ones. Right? So again, all the attributes that we actually collect, so we can take the data and then see what are the clusters that we have with that particular data. Right, so in any of these techniques, the outliers are the ones that we have to deal with. In some cases, the outliers are significant. In some cases, we want to omit those outliers. All right, so if you take, say, say for example, the salaries of all the NBA players. All right, so not all of them are actually earning that, are in the top range. Only a few of those are in the multi-million-dollar deals, but most of them are within whatever the average salaries that we have. So when you're doing the analysis for that type of data, so there are few outliers. We want to take them as a separate class, exclude them, and then do the analysis on the rest of the people. Alright, so here is an example. So we have, say, pick a department store, say for example, there are various branches of it, and then they ran a campaign, and then say for example, all of them were successful and one of them was not. And then we can go back and see what is the problem associated with that one. Alright, so in that case, that happened to go with the radio rather than the television in that scenario. Right, so when you're coming up with the clusters, so again it is a trade-off. So the tool is never going to tell you how many clusters are the best fit for that particular data. So you have to look at the data and see how it falls between those clusters. So the best possible case is everything falls into the cluster. So that is the difficult one. Right, so and then you also don't want very small clusters. So you want to have a meaningful representation of the clusters. So between the 2 extremes, having more people within the cluster or less people within the cluster. So somewhere between that, there is a trade-off associated between those. Right. So if the data mining is pretty straightforward, with just the click of the tool, then obviously you will not be talking about these various data mining techniques. So comparing the clustering versus the nearest neighbor. So the difference is the supervised, unsupervised versus the supervised one. So in this case, the K, how many nearest neighbors that you're actually looking at, that all drives the algorithm. The clustering, you still have, the tool will tell you how many clusters, say for example 5 clusters, you take a look at that and then you can change the clusters to 3 or you can go to 8 and then see how the data actually work. Alright, so but how are you finding this nearest neighbor? So if I take all your attributes and then how can you compare one person against the other person and say that they are closely related to each other? Right? So the data that I'm collecting, say for example, is your age, your income and so on. Right? So number of people in the household, number of cars and so on, you have all the data. It's all numeric data that we have. And most of the time they do the distance between 2 points. In this case, you take 2 people, take all their attributes and see what is the distance between those. The usual distance that we do on the XY, you can just apply it to any number of dimensions and then calculate what the distance is. So that is one. They also use the Manhattan distance. So if you go to Manhattan and then you want to go from point A to point B, you cannot go straight from point A to point B. You have to go like 3 blocks up, 3 blocks say south, and then 2 blocks east or west and so on. So that's how you get the directions from going to point A and point B. Right, so in some cases the straight line distance, some cases the Manhattan distance. So they use those techniques to come up with those data. Right, so in the data pre-processing, not covering about the data pre-processing here, but any data mining tool that you take, the first step you do is the data pre-processing. So the data that you get, assuming that somebody cleans the data for you, so you will be ready to jump into the data mining techniques, but you come here and then you realize that you're applying the clustering or the nearest neighborhood, and then you're looking at these 2 people and then compare the age and the income as the 2 attributes, and you're trying to do the distance between those and see whether they are similar or not. If you take a look at the difference between the age, so one person is say 20, another person is say 30, and you take a look at the incomes, so one person is having 100,000 as the income, other person is having 200,000 as the income. The income completely dominates the age. In the data mining model, the age will never have any role in that particular case. So what do you do in that scenario? How do you take the age into account? So in the pre-processing, we do all that stuff. We normalize the data so that all the attributes actually have a meaningful role in that particular one. So all those techniques you need to do before you actually do the data mining techniques and then come up with those data. So when you're coming up with the clusters again, so at what level you are going to start with? So here you have all the data in one cluster. At the bottom, you have each item as a separate cluster. And between those 2 extremes, so there is some place where you can come up with the ideal number of clusters of how you can group the data. And that's where basically you would do the analysis and see where to start in that scenario. Right, and then skip some of these details. Coming to the next one, decision trees are the useful one.
Excuse me.
Yeah.
So what is the primary attribute in the clustering mechanism that differentiate, or what's the demarcation I'd like to ask you, between the attributes that are used for clustering versus k-neighbor?
Repeat his question because people on the phone would like to, just because on the phone they won't hear in other words.
Yeah. So whatever the data that you are talking about, so in the case of the clustering, you are okay, so it's either one, it's mutually exclusive, but anyway. So the question is, the question is the differences between the clustering and the nearest neighborhood. So the attributes that, when you're talking about the clusters, so you're basically trying to group. So let's take this group, say for example, and if I want to come up with 3 clusters, so I could say, okay, the people sitting here is one cluster, people there is one cluster, people there is another cluster. So when I arrive at those clusters, I'm looking at all the attributes, computing the distance between each one of you, and making sure that you're very close with whatever the properties that you are trying. So that's all what I'm trying to do in the clustering techniques to group each one of you. When I'm coming to the nearest neighbors, so I'm picking you and I'm seeing who are the nearest neighbors to you. Now I have to compare your data against all the people and then come up with the list of whatever is the score that I have, and then I will pick the 2 nearest neighbors or the 3 nearest neighbors compared to those. The technique is the same, the distance measure that we are using between those 2. In the case of the clustering, we just group them and then say, okay, here is one group, here is one group, here is one group. In the case of the nearest neighbors, you are picking somebody and say, anybody, could be anyone here, and say who are all your nearest neighbors. So that is the difference between the
So the
clustering
cluster
and the.
is basically a superset of your neighborhood
Yeah.
entities, right?
Yeah.
This is for large data and it's for small data.
It doesn't. Yeah, it doesn't matter. Whatever is the size of the data that you're dealing. The same thing. The question is different actually between the clustering and the neighbor. In the case of the clustering, so we identify what the clusters are. We'll say, okay, these are the properties of the people in each cluster, and leave it at that. In the case of the nearest neighbor, there is no model here. So basically, you're given a data point, and then you want to determine who are the k nearest neighbors to you. So that is the question that we answer when you come to the nearest neighbor. The technique is the same. The distance measure that you use is the same.
So the basic differentiator here is that in clustering you have some common attributes, whereas the nearest neighbor you're only looking at distance as a metric.
The distance is one metric, but if you take the same data, just take the same data between whatever is the data that you're using for clustering versus nearest neighbor, same data, same attributes. In the case of the clustering problem, so we divide the people into say 3 groups and leave it at that. In the case of the nearest neighbor, the question that you will ask is, who are your 3 nearest neighbors? For each one of you will be arriving at that particular one.
So in nearest neighbor you're considering the attributes plus distance to identify.
You use the attributes to calculate the distance. Same thing in the clustering. So how do you group all of these into one cluster? So for any 2 people in the same cluster, the distance has to be small compared to the person in one cluster compared to the other cluster. So you have to do the distance in both the cases. In the case of the clustering, you group them and leave it like that. In the case of the nearest neighbors, you're not building a model here. So you're given a particular data point, and asking who are the 3 nearest neighbors. In that case, you're saying, give me 3 groups out of this entire data. Okay?
For data mining, the data has to be in a structured way, or it can be raw data too?
Yeah, okay. So most of the traditional data mining techniques, they were built on top of your relational data, but the same techniques could be applied for your NoSQL databases that you have. Even the big data that you have, so it's described in terms of the attributes, so you're going to apply those. If there is no structure for your data, so what is the problem that you are trying to solve? If that basically comes under the text mining categories. So the same techniques that you are using are applicable, but behind the scenes, the interpretation of that is different. So we're talking about the text, say for example, there's no structure in the text. You're just looking at the document and then seeing, okay, give me a cluster of the documents, give me a cluster of the documents. It's the same clustering problem that you are trying to do, but how you calculate the distance between 2 documents, that completely changes when you're talking about a structured numerical attribute data versus something that is in the free form and then trying those. You need to come up with the measure, and obviously people have come up with those techniques of how do you measure those ones. And so eventually they boil down to a particular structure where you apply those techniques. So coming to the decision trees, right? So it's basically a classification question. So when you come to the decision tree, so let me take we're just in January, but we can talk about our upcoming taxes. All right, so here, IRS is interested in determining whether you file your taxes correctly or not. So this is your last column, whether you cheated when you file your tax return or not. So for that one, so basically they have the data that they have collected, and some of the attributes, I'll just pick some of them. This is just fictitious data, not real data. All right, so when you apply for when you file for the tax, are you getting a refund or not? So that is our first column. Your marital status that you claim, and then whatever is your taxable income, and any other attributes that you have. So in the case of the classification, you have a finite number of classes where you are going to divide your data. So in this case, it is a yes/no question, or it could be a true/false, one of those, or it could be a finite number of output values. So if you want to classify, say for example, in your company, you have 4 levels of employees, and whatever the grade scales that you have, and you take all the attributes of all the data, how many years they have been in service and so on, what were their starting salary and so on. And then your output classification is whether they would be in the level 1 or level 2, level 3, level 4 and so on. So depending upon the finite number of values that we have, we want to come up with a model which tells us if you have this and this attribute characteristics, you will be belonging to one of these. So let's take this data, say for example, and what does the classification problem actually gives us. The decision tree is one of the classification techniques. And in the case of the decision tree, so depending upon each of the attribute, some of your attributes are nominal ones, as no or just a finite number of values here. Some of them are numeric ones. The numeric ones are the complex ones. If it's just a discrete ones, it's fairly straightforward to come up with the model. So say for example, your first classification of your data is to look at the refund attribute. So how many of them got the refund, how many of them didn't get the refund? And unfortunately in the data, for all the people who the refund, who are getting the refund, the value of the cheating is no in that case. And that 147 are those record numbers that we have. And then the rest of the data is there, so we need to take a look at the properties of the rest of the data. So for those people who didn't or not getting the refund, so now we need to pick some other attribute. So what is their marital status? So for those who are married, they didn't cheat. For those who are single and divorced, again we have an inconclusive decision here. Some of them cheated, some of them didn't cheat. So now we go to the next attribute. So here taxable income was there. And then in that particular range, so we were able to clearly get a tree for that one. So this is a very simple data where you have a nice tree where you can clearly identify each of the data records that we have, where it falls in these leaves. And you pick, say for example, the person with the ID 2, and then we can follow this tree. They didn't get the refund, they are married, and then they didn't cheat in the taxes. So you can describe each one of these in this case. So what do you do once you build the decision tree? So now you have the new data, and then you see basically walk down the tree with those values of the attributes that you are getting, and then see where they are going to fall into. And that's your prediction. So are they going to cheat or not? And then later you modify the model if you know that your answer is otherwise. Right, so this is the model where there are no errors, but again, no model is 100% accurate. So you're going to get the classification errors. So the data will not fit such neatly into those leaf categories where we can clearly tell that is the outcome, if that is basically the values that we have. The problem with the decision tree is there is no one decision tree which will classify the data. So there are several decision trees. Why did we pick the refund as the first attribute? Maybe I could come up with a tree like this, starting with the marital status, and then first whether they are married or not, single or divorced, and then the refund, taxable income, and so on. So for any given set of attributes, there are many ways that you can come up with the decision tree and the tools that you are going to use. So the idea is to gain as much information as we could from the data that is there. So which attribute that you are going to pick first, and then the next and next at each branch. So there is basically a set of formulas that is there. How much information you are going to gain, again, depends upon the data, the probability for each of the attributes getting those values. And then they calculate the information gain, and then pick the attribute with the maximum information that you can achieve, and that would be the attribute that they are going to pick at the top level. And then similarly, when you come here, depending upon how many, so the 2, 4, 6, and 9 are there, the rest of them are here at that node. So now I need to pick another attribute. So from that data set, which attribute is the one that is going to give you the most information? And then they come down that tree. So when you pick a particular tool, depending upon the technique they use, you're going to get only one tree, not all those particular options that we have. Alright, so once we have, so basically now we clearly have built a model, and then the new data comes, so we can infer what is going to happen. So we have various models. In the case of the regression, we predict what is going to happen when the new data comes in with those values. In the case of clustering, so once we have identified the clusters, the new data comes in, and then we can see which of the clusters it is close to, and then say, okay, this new one will belong in that cluster. The nearest neighbors, again, a new data comes, who are its nearest neighbors, and then try to learn something from their nearest neighbors. The decision tree, we classify the model, and then the new data comes in, and then we are going to predict the outcome for that one, whether they are cheating or not, or whatever it is, so the various outcomes that we have. The neural networks, briefly, I'll mention it to you here. Alright, so in this particular case, in the case of the neural networks, so it's basically how the brain works and how the neurons are connected. This is just a very simple example. So you have two incomes, the age and the income, and then again your prediction is basically whether you want to default on the loan or not. Alright, so you want to default on the loan or not. So this is another example where the normalization is required. So the income in this particular case will have a very high range, the age will have a very small range. You need to assign weights to these nodes and come up with some formula to describe whether you are defaulting with the loans or not. So again, you can do the normalization. There are various ways of doing the normalization. In this case, we are just assuming that all the incomes are in that 100,000 range. You divide by that 100,000. Again, assuming everybody is within the 100 lifespan, so you just divide by 100, but that's not the way that you do. You need the mean and the standard deviation to actually do the normalization of the data for those particular attributes. But now, so before there's a huge difference between 47 and 65,000, but now once they are normalized, it's 0.47 and 0.65. So both of them are going to have an equal important role in the model that you are going to pick. So any of the data mining models where the numeric attributes are there, the first step you would look at the attributes and see if they require the normalization of it. And once you do the normalization, then you have more meaningful results associated with those. Otherwise, some of them will not have any significant role in the data. So in this case, whatever is the score that you are going to come up with, so you will say 50-50 between the two outputs, whether you are defaulting on the loan or not, and then you can come up with those outputs. Alright, so and again, the new data comes, then you need to change the model corresponding to those. Another important one is the rules, association rules. Right, so they also call it the market basket technique. So this is the one that you encounter every day. So you go to Amazon, and then immediately it shows, depending upon your previous purchases that you did, it will give you recommendations, or you get in the email about what they want you to buy next. Alright, so Netflix, whatever the movies that you watch, based upon that, they will give you the recommendations. So Netflix is a good example to compare all these differences between the data mining versus the analytics part. Right, so initially they will show you all the top movies, right? So whatever the top movies, you're basically looking at how many people have viewed each of the movies, and you're basically picking the top 5 or the top 10 and then showing, okay, these are the top ones that people are watching. So that's purely analytics, no data mining that is involved there. You're looking at the history and then coming up with the results. The hard part is the recommendations that were given for you. So based upon the movies that you have watched, so what are the movies which have similar characteristics for that particular, based of your history. So those are basically also called the market basket analysis. So because if you go to the grocery store and whatever the items that you are buying, so obviously they have the history of your transactions. And then how can they use that particular data? So what are all the things that are going together in each of these baskets? Think of the basket as whatever is your shopping cart. So based upon that, the commonly occurring ones that are there in each of the transactions, so they could use that information for their business purpose, whatever is the business purpose that they are trying to solve. Or they can send you more coupons based upon the things that you bought and the things that you didn't buy. They know that you are likely to buy those ones. Right, so you buy a laptop today, and then immediately you will get the offers for buying the purchasing plans and whatever the accessories that you need for those. So all those things are coming from the association rules. Alright, so and again, for each of the rules that you're going to come up with, we need to somehow tell how likely it's going to happen and how strong you can say that that rule is going to be applicable. Alright, so in the case of the rules, so we have this form. So how do you describe those rules? In all the other cases, so we have, in the case of the decision tree, we have a tree. We can also describe the tree in the form of these rules. But in this case, if these conditions hold, then this is going to be the output. Alright, so very simple example here. So if you buy the paper plates, then you are likely to buy the plastic forks. So now you walk into the grocery store, and the first thing you go and look for is the paper plates. So the next thing is you need the forks. And if the forks are not there next to it, are you going to be happy or are you going to be upset? Alright, so if they make you walk all the way to the other end of the store to get the forks. Alright, so how are they grouping? Some of them are basically, some of the things are usually common sense, but typically when you have this type of data analysis that you are trying to do, so what are the things that are commonly associated with each other? So you need to verify against the data that you have. So based upon those associations, you can do it. Alright, so next time when you go to any of, so take Home Depot, say for example, whatever the project that you're doing, you need several things for that project, and how quickly you can find those and come out of the store, you'll be very happy. If they are everywhere across the store, and then you basically have to go for each one of those, then you'll get frustrated with those ones. Alright, so for each of these rules that you're going to come up with your data, so we need to tell how accurate it is. Alright, so obviously all the people who are buying the paper plates, they are not just buying the forks. In some cases, they are buying maybe spoons or whatever, other things that they want to buy, cups and so on. So there are other rules also applicable if you're just going for the paper plates. So between all those things, so how accurate is this rule? So is this 75% accurate that whenever you buy the paper plates, you're going to end up in the plastic folds? Or is it only 10% accurate? So those two, that value will basically determine how important that business rule is going to be. Oh, coverage, so based among all the transactions that you have, it's not just the paper plates and the plastic forks that you are buying, there are other things as well. So is this only applicable, say, to 1% of your total transactions or 10% of your transactions? So what is basically the scope of these values that you're dealing with? Right, so in some cases, you want to act upon those and then take the appropriate decisions for those ones. Right, so good examples here, if you go and buy the cereal, then obviously you'll be ending up buying the milk. And this is accurate 85% of the time, and 20% of your entire transactions in the database. So suppose have these cereal and the milk. So there is something that you could use and then act upon those ones. Right, so what do you do with the rules? So that's basically gives you scope of your business problem and then determine what to do with those rules. Right, so you can take the things that are there on the left-hand side and then act upon those. Take a look at the things that are there on the right-hand side, and that would be your target for your next purchases. Right, so and then you start getting the emails about those ones and then work with those. Right, so as far as the tools are concerned, so if you go with the classic ones, so if you are SQL Microsoft Shop, then you have the SQL Server that we have. It has all the analysis services, the reporting services, and the business intelligence studio for the data mining part. Oracle has its own suite of data warehouse and big data. And if you come to the MicroStrategy, they have their business intelligence tools. IBM bought the Clementine SPSS and Cognos, SAS, and so on. A good resource for you is to go to this link, kvnuggets.com, and then it will give you alphabetical list of all the data mining tools. Right? So you have all the slides on the website, and then at the end I'll show you that link, and then you can take a look at those as well. All right, so quickly we'll go to the applications, and then we'll take a break, and then we'll go to the demos for the tools. All right, so I'll just go very quickly. All right, so what do you do with the data mining techniques? So as soon as you graduate from college, immediately you'll be getting information for the donations. All right, so be ready for those ones. So okay, whatever is the situation, doesn't have to be a college or whatever it is. So that's one, alumni, how likely are they trying to make the pledges? As the students are enrolled in the university also, we can take a look at what is happening and then act upon those ones. The market basket analysis we talked about, so that's basically not only to the typical store. So when you go to the website and when you're looking for a particular item, and then the pages that they're going to display the products, they have to be related to each other. Right? And similarly, when you do the search on the Google, and the results that you're going to see, they are related to what you're looking, otherwise you will not go and go back to that one. Alright, so if you want to become rich in the stock market, or in basically trying to predict how the gold is going to go or the oil is going to go, then we can take a look at some of the typical data mining techniques they use to predict what is going to happen. So all their lives are dependent upon those predictions. The lotteries, so this is one huge market where they use the data mining techniques, and the revenues are very huge for all the states that are involved, and you see all those millions and millions of dollars that are going into the lottery. And then basically the data mining techniques are used to introduce new games, and whom should they target? Unfortunately, the wrong people they target, but anyway. So and then that's one place, huge place where that works. IRS, recently there was an item that they are going to audit fewer number of people this year, so we can be happy with that one. But data mining techniques are the ones that they use to pick the people whom they are trying to audit, and then the auditor comes into picture at that point once the tool selects the people for auditing or not. All right, so and then there's one. Fraud, both in medical industry, any insurance industry, obviously there is a lot of fraud, and how are the transactions actually flagged. So the typical fraud streams, say for example, services that were not performed, they were billed, diagnosis, falsifying it, and then doing more tests and so on. So all those things, the insurance company is interested in finding those. Right, so those are some of the examples where this one comes into picture. Text mining, so basically all the text data that you have, so you want to see what are the relationships between those. The same techniques that we have seen are applicable to the text mining as well. It's purely unstructured data, you have to convert it into the structure. And it's very beautiful how they take your text data and then come up with the attributes. Each word now becomes an attribute, so that's what the structure comes into picture. And unfortunately, the same word means different things. We have synonyms we have to work with. we had to look at the stems of the words and so on, and then come up with the model. So once it's transformed, then you can apply those. SQL Server has a beautiful text mining tool actually to work with those ones. Right. And then obviously the scale that we are working with the text is much larger. And then there are various things that you need to do for the text. So from the raw text, how do you convert it into the structured format? How do they do the indexing? You try to search something, immediately you get the results. So how could they give you the results so quickly? All that is how they do the indexing and then look upon those. Alright, so yeah, just 2 minutes. Alright, so crime pattern. So if you follow this A field, so some of the police departments actually predict before the crime actually happens, and they are waiting for you there. So that's basically coming from the data mining techniques. All of them have data mining techniques. Depending upon the history, they can actually tell what likelihood the crime is going to happen in that neighborhood at a particular moment, and then act upon those. All right. So there are various studies that they did, and then using the data mining techniques. IBM is big in this one, deploying the solutions for the police departments for the crime patterns. Right, so another useful one is the call center. So whatever the problems that you have, you call the call center, you describe what your problem is. Immediately that guy on the phone has to come up with some solutions for you. So whatever the things that match your problem, he is going to talk to you about those ones. So that's again where the data mining comes into picture. Surveys, all the surveys that people take and analyze it, part of it is analytics. When you ask the people to do 1 to 10 and then do the summary of those and then do it. But how do you predict how they are going to do the surveys? And then some of them is free text also, the responses that you give, how do you do the analysis for those? So those are various examples of those. If you come to the web mining, so that's another place where there's a lot of data that you have. And then if you're just looking at the logs and see what people visited, that is purely analytics that we are talking about. So for coming to the web mining part, so you're interested in actually, if it's a merchant, if it's an e-commerce merchant, then you want to basically see how you can build up the websites. They have to be responsive websites. So depending upon who the customer is, your output for each customer is going to be different, what products you are going to see and so on. So all those things happen with the data mining techniques. So it's all text mining, web mining, data mining, the techniques are the same. And depending upon the context that you're using, traditional data versus text data versus the web data that we have, they use the applications for those. Alright, so web mining is an entirely different topic, so I have the slides so you can take a look at those later. Right, so there's some of the references that you can use to take a more detailed look into those ones. Alright, so that's the first part about the data mining. We'll take a break and then I'll show you the tools. There's one tool called Vika and another tool called R. We'll concentrate on those two and then basically see the data mining versus the analytics parts of how you can use it. They're open source, very easy to use, so you can try exploring those as well.
Suresh, when you do the search on, say, Google search about a particular item, then you can see all related ads popping up. Is it the data mining or is it something else?
Purely data mining,
Thank you, Doctor. Thank you.
We'll come to the questions.
Thank you, Dr. Suresh. We're just going to take a 10-minute break. I don't know what's going on, that's okay. We're just going to take a 10-minute break. And people who are on the phone or web, please, you can go and take a break too. We'll be back in about 10 minutes. There's some tea and some light snacks. When you get out of the what your name is, what you're doing, if you're in the IT industry, software industry, whatever, data mining, and whatever you want to say about yourself for like 30 seconds, 1 minute, whatever you want to say. Give a brief about yourself. So